Thank you, thank you. All right, guys, so we're going to be talking about jet lag poop. This is actually from an article. I dropped the article link in the chat and in the Discord in case you want to check out some of the other figures later. But basically, the whole big title, all it means is jet lag poop, so that's what we're going to be talking about. So things that you need to know about for this presentation, it's kind of two domains, right? And the first thing that we're talking about is the circadian rhythm, which is way more important than you thought and also crucial to the function of every cell in your body, and also the microbiome. That's the collection of all of the bugs and germs, microbes, bacteria that all live inside your intestines and on the skin, on your hands and everywhere in your body. And that's also way more important than you thought and also crucial to your whole body's function. But a little more information about these things. Circadian rhythms are about 24 hours. They're cycles. They involve every cell in your body, and the microbiome regulates all of your body's functions for the most part. Also, your body is 10 times more microbes than it is you. You have 10 times more microbial cells making you up than there are your own cells. So that's what we're talking about. We're talking about the intersection of kind of these two things. So like the way that you might think that these things interact right now is you might think that like you decide when you want to eat, and when you eat decides when you poop, and what you eat decides whether or not you're prone to obesity or not. And that's my obesity emoji, work with me. And that you decide when you're going to sleep, but maybe like the sun and the moon also kind of decide when you're going to sleep, and that you just decide what your circadian rhythm is. And that's not actually how this works. And the microbiome is just like, what's that? That doesn't have anything to do with anything. But actually, like if I were to explain to you how all of these things interact and overlap, it would just be like a messy spider web of arrows where all of them inform how all of them work. And so we're going to talk a lot about how your microbiome influences your circadian rhythm, and how your circadian rhythm influences your microbiome, and how they affect behaviors like when you eat, when you sleep, and if you get heavy or not. So there are a bunch of circadian rhythm disorders that people can have, and the one that we're talking about is jet lag here. So jet lag, it's, if you've ever traveled outside of the country, you've taken a long flight, you know what that's like when you wake up the next day and you're like, oh, I am not in the right time zone. And so it's just a graph of what some of these other circadian rhythm disorders look like, but we're focusing on jet lag, where you're on a standard cycle for a while, and then all of a sudden your cycle just gets shifted by like 6-8 hours, something crazy like that. But all of these circadian rhythm disorders, they lead to really bad health outcomes. And this affects a lot of people who work nights. So nurses, security guards, things like that. And it leads to obesity, cancer, heart disease, all sorts of things. And so we're going to try to look at why that might happen. So first part of our experiment, we're going to jet lag mice, and then we're going to see if their bacteria gets messed up. So here's my schematic. We took mice and we made them eat either when it was light out or when it's dark out. Mice, as you might know, are nocturnal. They like to eat when it's dark out. That's when they like to be awake. But we took mice and we made half of them eat during the day. And what we did is we sequenced the bacteria. We figured out how much bacteria of each different kind was in their body at different time points around the clock. So every 4 to 6 hours, right? And so we can see here is the blue line, or the mice that ate normally. And you can see that they had different levels of bacteria at different times. During the daytime, they were getting, the bacteria was multiplying and reproducing, and they were getting more of it. And at nighttime, it would drop down. And this is important because bacteria do a bunch of different functions in your body. So some are more important when you're digesting food, and some are more important when you're not. And so you see the mice that were light fed, it's completely opposite, right? Instead of having this much bacteria then, they have that much bacteria then. And it's kind of like opposite graphs there. So then we go into the second phase of our experiment. And what we did is we decided we're going to jet lag mice. We're going to feed them terrible food, high-fat diet food. And then we're going to take the poop out of those mice, and we're going to put their poop into other mice. And we're going to see if that poop messes up the mice. This is called fecal transplantation. And it's important because what you're doing is you're taking all of the bacteria from one organism and putting it into another completely different organism, so that there's nothing else affecting them besides the microbial content of their poop. That's the only variable, right? So what we did is we took mice, and then we divided them into two groups. We had one group on a light dark cycle where they were sleeping and being awake and eating food whenever they wanted, but whenever they ate food, it was terrible fatty food. We had another group of mice and we jet lagged the crap out of them, quite literally. What we did to those mice is about every 3 days, we shifted them ahead 8 hours. It's kind of like if you flew from wherever you were 6 time zones east every 3 days. And they did that for weeks upon weeks upon weeks. But they also fed them really terrible food. So then we took the poop out of those mice and we put them into new mice to make sure that the only thing that was affecting those mice was the bacteria from the poop that they received. And then we decided to see how fat did these mice get. And what you see is the group of mice that were doing their normal sleep wake on their normal light dark nocturnal thing. Even though they were eating bad food, they did not get nearly as heavy as those mice that were jet lagged were. The jet lagged mice are red. And in science, whenever you see 2 stars above a graph, that means that it's really important as a result. So yeah, the jet lagged mice got really fat. Okay, interesting. Let's take a look at what that looks like in an MRI. Well, on the left, you can see that the mouse on the right side is a whole lot bigger than the mouse on the left side. And then on the right, you can see what happened after they did the fecal transplantation. So these were into mice that, most importantly, were not jet lagged. These mice were living their normal mouse life until they got the bad poop. And then once they got the bad poop, they had the bad poop microbes and it made them get heavy. And so on the bottom left, you can see what happened. The red graph is when we took the poop from the jet lagged mice and we put them into mice that, again, did not do the jet lag. The only thing that they did is they received poop. And compare that to that black line of those mice that were not jet lagged. All they did is received normal poop from other mice. And then on the right, you can see that the mice who received the jet lagged poop, they had problems with their activity too. They were awake at all times of the night and day and eating at all times of night and day. So it messed up their circadian rhythm too. So the big finding of here is that, you know, mice who have a circadian rhythm that are messed up, it messes up their bacteria, and their messed up bacteria create all sorts of problems. They heighten obesity risk. So then they did this experiment and they were like, it's not enough that we're just doing this with mice. We need to bring people into the mix. So what they did is they decided that we're going to jet lag some people. So they had 3 groups of people. They had people who were our controls, that's on the left side. They just did their normal people thing, awake during the day and asleep at night. And then we had our middle group. And these were people that we subject to that same kind of jet lag situation where we're going to take their poop right after they fly across the world. And then we had the group on the right, and they had experienced jet lag. They had taken a big flight across the world, but we'd waited a few weeks before we took the poop out of the people. Then we took the poop out of all the people, and we put all the people poop into mice that didn't have any bacteria. And then we fed them crap again. We fed them a really terrible diet. And what we saw is we saw that the mice who had gotten the poop from the jet-lagged people developed obesity, whereas the mice who had gotten the poop from the people who weren't jet-lagged, they did okay. So the moral of the story is if you have to take a flight, don't let someone put your poop into a mouse. It'll get fat. And that's kind of the best we got.